He's adding power. And there we go. Liftoff. Not something you see every day.
No, it's incredible.
Now he's going to rotate his nose around, and then they're going to start heading over to the lake bed. And there he goes. So he's going to go out over the lake bed now, and there's a compass rose out here, and they're going to make once they get the vehicle oriented, they're going to make a couple of 90-degree turns to basically update our inertial navigation system and our attitude system, and then they're going to do a couple of low altitude passes, basically to burn off helicopter gas and get some high speed passes on our vehicle, basically to get some aerodynamic data for our flush air data system. That's the system that we get angle of attack and airspeed and things like that from. So we want to get some low altitude testing to that. Helicopter will burn off a little bit of gas, and then once they've done a couple of passes and burned off some gas, then that will enable them to go up to higher altitude, closer to drop altitude. And then they're just going to do racetracks and practice the run-in line, getting into the drop box with a team.
Sounds like a lot of exercise the Dream Chaser is going to have doing all these laps today. And I think just that image, just majestic is the word that comes to mind, and just having the sunrise and that beautiful spacecraft being lifted up and just seeing it in the air, it just gives you chills how beautiful the vehicle did. So your assessment of how things looked so far? So far they look good. I need to see all the data, and I can't see it here, but you need to see the telemetry. I need to see the telemetry. But so far everything looks okay. Their op here lifting off looked great, and so we're going to learn a whole bunch right now. So that's why we test. So, Steve, I want to take a couple more questions from those watching us out on Facebook. Daniel wants to know, how long do you think the Dream Chaser will be in commission? Well, the Dream Chaser, the vehicle itself is designed for each airframe is designed for 15 flight reuse as a minimum, and we'll get more data once we fly it to see what it really is. And that's one of the greatest aspects about the Dream Chaser is the fact that it can be used 15 times. Basically, it lands back, some refitting happens, but then it can go right back up into orbit. Yeah, as far as the Dream Chaser program itself, we have designs on flying long past space station and basically being a permanent presence in low Earth orbit. So we're hopeful that the program lasts long past my career, at least. Maybe not long past your, I don't know. Well, you're a lot younger than I am. Around the office, a lot of people like to say that the Dream Chaser is literally going to change the way the world goes to space. The Dream Chaser spacecraft is made by Sierra Nevada Corporation, and we actually have a question from Brooke on Facebook who says, tell us more about what SNC Space System does. So SNC Space Systems is one of our business areas as part of SNC, the overall company. But the Space Systems group is located in Louisville, Colorado, so we're right near Boulder, actually between Denver and Boulder. And what our group does is, besides the Dream Chaser and what we've been talking about today, we also do satellite components. So we do things like precision gimbals, thermal louvers, precision, like we built the wheel mechanisms for a lot of the Mars rovers. As Kimberly mentioned earlier, we've been to every planet in the solar system that NASA's gone to. I think we've been to Mars something like 12 or 13 times. We built parts for all of the rovers that are currently on Mars now, and all of the systems and on future systems. And so we build a lot of precision components for satellites and things like that. We also have a small satellite group that builds small satellites. Recently we put up a constellation of 17 satellites called Orbcom-2. And those are small satellites that actually track shipping around the world. And so we have a satellite group, and then components group, and then then of course the Dream Chaser program that I'm part of. Additionally, we are just starting another program at NASA called Next Step 2, where we're building a prototype habitat for their Deep Space Gateway. That's the next program NASA's working on, a Deep Space Gateway that will be in lunar orbit
constellation NASA's rocket will be going to with Orion, and basically the plan is to stage interplanetary missions out of that Deep Space Gateway. So we're a part of that as well.
That's incredible. The idea that you could live in space, go deep exploration, that is incredible. Yeah. And part of that, I want to give a shout out to our office in Madison, Wisconsin, which is actually making fresh food on the International Space Station right now through the Veggie and APH program, and really advancing plant science. And if we want to live in space or go deep into space, as you were just talking about, we need to be able to eat fresh food. So that's an incredible program that SNC is a part of too.
Yeah, and to your point, Madison group, that one of our groups up there, they not only do the Veggie experiment that's on space station, do a lot of plant work. Recyclable. Some of the if you saw the space station astronauts eating lettuce in space, things like that, that was Orbitech, our group up there, that did that. They also build rocket engines, and they're building rocket engines for our orbital vehicle, and they have a outstanding technology up there, a good group of folks, and so they are heavily invested in space as well, and a critical part of our organization.
All right, I think we're going to try to wrap it up here, so I'm going to take one last question from our Facebook land. And we have, let's see, Brian is asking, can mission control take control of the vehicle if the automated system fails? So what happens with that?
So mission control can take control of the vehicle. However, for this particular flight test, once we release, the time of flight from release to landing is about 60 seconds. So they can send commands, and in fact they're set up to send backup commands to mode the vehicle in certain ways. Like for example, today when we come back in and land, we're going to set the system automatically to deploy the gear when we get to about 200 feet. If for some reason that doesn't work, then mission control can manually command it. So the mission control can manually command everything. However, when you have a really short time of flight and not a lot of time to make decisions, generally speaking, the way we deal with that is rather than having the ground sending a command, we have backup systems that protect us if the first command doesn't work.
Well, Steve, I know you probably have just a few things that you have to do today, so we should probably close up this segment, but it has been a pleasure to get your information and just have you kind of do a play-by-play as if this were a sporting event. And getting your information was incredible, and I know everyone watching is so grateful for you to take the time to give us your expertise, and we're so grateful for everyone who watched today. Thank you for tuning in right here from NASA's Armstrong Flight Research Center. We're so excited to bring you the Dream Chaser captive carry test. So on behalf of Sierra Nevada Corporation and the whole Dream Chaser team, we want to say thanks for tuning in, and don't forget to chase your dreams.
Thank you. Thanks for joining us.
Bye, everyone.